Hello and welcome to the ProtoPod, the podcast for engineers, innovators, entrepreneurs, and trailblazers shaping the future. Here, we dive into the cutting-edge worlds of prototyping, aerospace, rapid manufacturing, mass customization, and beyond. I'm your host, Jordan Rose. In today's episode, I got to chat with Rahul Goel, founder and CEO of Nordspace. Nordspace is breaking barriers in the aerospace industry with its bold mission to launch Canada's first orbital-class rocket. Let's get into the episode.
Amazing. Thanks so much for having me, Jordan. It's a real honor. Huge fan of the work you do, and excited to talk about that.
Yeah, you're the CEO and founder of Nordspace. Looking through your website, I do see a lot of similarities in the mission and vision of your company and Protocase. So it seems like a very suitable conversation for our first podcast. So super excited. So before we get into talk about Nordspace, I do want to learn more about your company. Do you want to give me a little bit of information on your background, kind of how you got to Nordspace, Rahul pre-Nordspace?
Yeah, for sure. And again, congrats on the inaugural episode of the podcast, and thanks for having me as your first guest. An honor. A lot of my life pre-Nordspace has sort of followed the same theme. I've always been obsessed with space and all of that, like a lot of young boys from a pretty young age. Dinosaurs in space sort of formed the majority of my life, and I like to say, like, I never really grew up. I'm still sort of that same kid trapped in a man's body, I guess. And that's really set the tone for most of my life. Born and raised in Toronto in the Jane and Finch area. Really proud of where I came from and all the work that sort of led up to this point. I went to the University of Toronto for aerospace engineering, built other companies between that aerospace engineering degree and founding Nordspace ultimately. What was a really big part of the student experience overall, and Protocase played a big role in that. Would love to talk about that at some point. But built everything started with Lego Robotics in elementary school. That was a very formative and pivotal point for me, and took that to building windmills for competitions, math competitions, science competitions. I was totally a nerd. Eventually, larger robots, satellites, rockets, things like that. And I really spent most of my time outside the classroom and mostly tinkering on personal projects or academic extracurricular projects and competitions like that. Had a bunch of twists and turns along the way. Went to business school before going to aerospace engineering.
Oh, interesting.
Yeah.
Very cool.
Oh, sorry.
No, keep going. Sorry.
Sorry. I thought you were. Do you want me to start again, or do you want me to?
No, keep going. Keep going. You keep going. Business school.
Oh, okay, cool. Yeah, a bunch of twists and turns. Went to business school to become a chartered accountant, and that didn't really fit. Ended up in aerospace engineering, and then one thing led to another, and eventually founded Nordspace.
Yeah, that's awesome. I did not expect that, especially given the history, your interest in technology. I can very much relate to dinosaurs in space. I spent a lot of time with the Magic School Bus as a child, kind of dreaming of very similar things. So I can absolutely relate to that. So immediately out of high school, you go to business school, then you transition to aerospace engineering. You did mention working with us in the past. I know that you were a competitor at the University of Rover Challenge. Can you talk to me a little bit about what that experience was like for you in terms of, I guess, upgrading your level of innovation? Because I have visited as a sponsor the URC competition, and what I'm always struck by from all the competitors is the sheer volume of innovation that takes place in the Utah desert every year is pretty unfathomable. So yeah, can you kind of talk about what that experience was like for you and how it kind of built you into where you are today?
Yeah, for sure. Jordan, a lot of my life, my natural state of being is definitely being an engineer, working in the garage or a basement or something like that, soldering or doing something like that. But I found myself in a variety of roles throughout my life where I've had to take the leadership to build teams or build a company or sort of get things started. And U of T's rover team was sort of the same deal. I went to a program at U of T called engineering science, very theoretical, not very practical. And U of T didn't really have as many practical student experience teams. So, and I really wanted to start something in that category. When I was at York for business school, Schulich School of Business, they had a rover team there, which I participated in spite of not being an engineer in one of the engineering programs. But wanted to do that at U of T. So founded Robotics for Space Exploration. I'm so glad to see that the team still exists and doing far better under new leadership than what I was able to accomplish there. But it was a very grassroots effort. We had basically zero budget. There was a tremendous amount of scrappy work, but there were one or two sponsors and supporters that really pulled through for us. And one was Protocase. And only today do I realize how much of a deal that really was, when Protocase invested a tremendous amount of materials, labor, and just like kind engineering services, all in kind, to present these amazing rover chassis, wheels, and all these things perfectly machined, something that I didn't really fully appreciate back then. And I remember distinctly getting to my home delivered from the postman these giant boxes that said Mars rover on them. And I used to be absolutely thrilled to get these. The postman was scratching his head wondering what this kid is doing with Mars rover parts. But it was just the greatest feeling ever. And now I realize how big a deal that was. So first of all, thank you to Protocase and Protospace for doing all that. And I look forward to paying it forward with Nordspace as well. But that's really that was a big part of my life as well. Many thanks to you all.
Yeah, that it's definitely something that we're happy to do. It it enables us to kind of show young students who maybe don't have manufacturing experience, kind of what the power of quick turn can do to accelerate your projects. Again, as I mentioned previously, like I think reading your website, I think you've taken a lot of those ideas to what you're doing with Nordspace, which I think is amazing for your customers as well. I did pick up on one thing that I thought was really interesting in there is you said that URC was a great learning opportunity for you in terms of growing your leadership. So obviously, I think you were being modest there too. I think you were probably a very effective leader in that capacity, but very nice of you to say that others after you took it to the next level. How do you think that led into you founding other companies prior to Nordspace, and what role did that play?
Yeah, honestly, a huge role. I wanted to start Nordspace, at least for much of my life. And one of the reasons I started RSX, our U of T rover team, was I had this very long-term, 10 to 15 year long vision where, hey, we create this culture at this robotics team, and then eventually, I find Nordspace, and then I'm able to recruit and hire from this robotics team that I sort of set this culture that I think is what Canada needs and what's right. And they're trained in undergrad, and then they end up at Nordspace and are able to work on industrial scale projects of a similar sort. So I was very, very thrilled and proud to see that sort of came to fruition earlier this year, where the first individual that, he joined RSX after I left, went through the whole process with the team. A lot of the foundational cultural elements are still there. Our motto is the sky isn't the limit, and that's something that we maintain at Nordspace too. And he joined Nordspace, and he's our lead software and avionics engineer, Human, and he's just phenomenal. And it really kind of warmed my heart that, hey, it all came full circle, and we still sponsor and support that team among many others, and are really excited about creating this sort of feedback loop within the Canadian ecosystem, where student engineering teams are able to feed into industrial and commercial companies like Nordspace and Protocase and Protospace. And it was really great to see that happen. So that was one big win that still reaping the rewards from today. But overall, yeah, tremendous leadership experience, learning how to work closely with engineers, learning how to figure out how to manufacture and do things at scale, learning how important design for manufacturing is, not just designing something that looks great in CAD, but is impossible to actually implement in real life. And then just building something that inspires people, I think is one of the greatest things that I was able to carry forward.
Yeah, I love that. The sky isn't the limit culture. That's it's really amazing. That's something that organizations, I think, is the key to successful organizations, is having the right culture. And it sounds like not only have you cultivated that at Nordspace, but you also have a little farm system going on,
Yeah,
so you can bring
exactly.
people on who already are aligned with those visions, which is awesome. Um, about Nordspace, can you kind of touch on how Nordspace got started? So now that you've gone through, you've started a couple businesses, you've got your leadership experience. How did Nordspace come to be?
Yeah, so Nordspace, it's a very serious attempt at sort of reinvigorating the Canadian space economy and building something that I think has the potential to sort of lead the charge for the next couple of decades when it comes to Canadian space. But bringing it back down a little bit, as I mentioned, always excited about space. Really proud as a Canadian of all our amazing accomplishments. Our astronaut program, to being the third country to have a satellite in space, even though we didn't launch it, but still amazing accomplishment back in 1962. Canada Arm and all our contributions to the ISS and everything like that. Really great stuff. This is what got me excited about space. Just seeing the amazing things Canada did. But over the last decade and a half, seeing Canada take more of a participatory role and being taking a bit of a back seat. Not that we aren't growing, but it's just that there are dozens of nations growing so much faster than us and outpacing us with investment and innovation. It just it didn't feel good because I went through the system, graduated with a degree, and all of that, and now it felt like it's my turn to do something and make sure Canada remains a leader in space. And that's really the core impetus for what became Nordspace and what it is today. I very decidedly didn't want to just build a small technology company where we're building some small components like a small satellite bus or little thrusters or anything like that. We're doing all of that, but really something bigger that can be the linchpin, that can really be what other industry and companies form around. A big vision, no doubt. The Avro Aero story is also something that really touched my heart from a very young age, and got me very excited, but also heartbroken as well. And I was committed to ensuring that we don't have another Avro Aero moment in Canada again, which I sort of see with so much investment and so much talent leaving in droves, especially from aerospace and especially from the rocketry space, leaving from Canada. So that's really what emotionally what got Nordspace formed, at least in my mind. But then the immense economic opportunity. We have the opportunity as Canadians for our space economy to be a $40 billion space economy by 2040. I see no way of achieving that until we internalize the gains and capture the whole value chain of a space mission, and that includes launch. Canada has never launched anything into orbit before. We're the only G7 nation, the only Five Eyes nation that has never done that. And we have to turn the tide. So that's why Nordspace was formed. Nordspace being a full space missions company, where we're building spaceport, we're building a launch vehicle, and we're building a small satellite division so that we can have a true homegrown end-to-end space missions capability right here in Canada. It's been a great journey so far over the last 2.5 years, and we're only getting started.
Yeah, I like that. You truly are a pioneer in your space. I mean, hats off to you for identifying that as an issue, across the entire country and taking the leap to address it. It's amazing. Also, I like the approach in that you're kind of saying that in order to really tackle this problem, it has to be an all-encompassing solution. Very much, again, when I read about Nordspace and about in-house manufacturing and everything that you're trying to do, keeping things under the hood so that you have access to everything that you need to make it happen. So why don't we go into the launch piece? Because I was really interested in that for a multitude of reasons. Obviously, as you've mentioned, we've never, as a country, launched before, and that's part of your mission is to get us there. Talk to me about what that looks like in the future for Nordspace. What are what's on the horizon for launching?
Yeah, great question. And we have had a great history of launch in a sense. We never launched to orbit, but back in the 60s, we had the Black Brant program and the Rocket Research Range out in Churchill, Manitoba, and things like that. So not to take away from some of the work that's been done, but really nothing remotely close to what other nations are doing. We have a lot on the horizon. We've been moving at a breakneck pace at Nordspace for a lot of reasons, not just because we have an incredibly smart team, which we do, folks who worked on Starship at SpaceX, to cameras that are now on the moon, to Canadarm and all kinds of other great pieces of tech, satellites. We have a very talented team, but there's a lot of other reasons to be optimistic. We've been moving really fast because we've invested, like you mentioned, in-house manufacturing. We have our own powder bed fusion facility for metal additive manufacturing that's allowed us to iterate and design, manufacture, test, and qualify things at record pace. We designed and built our first stage Hadfield rocket engines, within a matter of 10 months, from literal clean sheet designs to a qualified engine, almost entirely qualified. And we're looking to fly it as early as next year. So we're breaking ground on Spaceport Canada next year on the east coast of Canada, and we're launching next year as well, a suborbital rocket, which would be the first commercial liquid rocket launch in Canadian history, and really set the foundation for us over the next 2 to 3 years to develop out our orbital rocket program, which also is being aggressively developed at our test site with turbopump work and orbital scale rocket engine work. And closer to the end of the decade, around 2027, 2028, would be the inaugural orbital flight from Spaceport Canada. So next year is going to be huge. It's going to really make history in a lot of ways at Nordspace. And it's not just about Nordspace. This is really for something that we like to say, it's on our mission, passion, everything. It's for all Canadians. We really consider this a national initiative. Of course, economics and the security benefits and the sovereignty and all of that will turn this into a great business, no doubt. But this is really something that we're doing for Canada in a lot of ways as well, and couldn't be more proud. So 2025 is going to be great.
Yeah, that's a rapid velocity that you're moving at. Next year absolutely being a key milestone in that, and then very shortly after, in the years coming, going from suborbital to orbital launch. I did read that you had the planned launch site has a wide range of trajectories that it is capable of launching from, and that has the ability to put satellites or launches, whatever it may be, into multiple different orbital paths. Why is that important?
Yeah, well, I think one of the things that I try to promote is not just making Canada a place where something is possible. We just scrape by rather, and make things possible from a regulatory standpoint, a policy standpoint, or technology standpoint, but actually make it favorable. I think that's really, really important, that we should have a competitive edge and advantage. So having a wide range of launch inclinations, for example, gives us an edge, not just for our own missions, but eventually to allow other nations to launch their own vehicles from our spaceport, one of our first domestic spaceports. So that opens up a wide range of opportunities for us to hit equatorial orbits to our very important polar orbits that assists with everything from protecting our Arctic, which is a really important topic, to building systems to help remote Canadians be able to communicate with each other through satellite communication over time. And then, of course, the standard orbits that a lot of satellites go to is something that would be possible as well from that location. People often think when they hear you're building a spaceport in Canada that we're launching from, Santa Claus's workshop or something like that, far north. But actually, it's at a latitude of about 46 degrees, basically where Seattle is. And when people hear that, they're like, "Oh, wow, okay, that's not that bad, actually." And compared to other spaceports around the world, it's actually very well situated. Certainly, it's not Florida, but it's amazing, and we're working very closely with the government to make sure that this is done safely and effectively, so that it becomes a favorable place to launch from.
Yeah, so it broadens up the scope of application, which again goes to that idea is we can keep more things internal to the country and allow us to do everything that we need to across the board in terms of orbital launches. That's really cool. You did also mention in there when talking about what you're doing at Nordspace about your rapid pace of movement and removing latencies in projects. Really, I think the 10-month window was what you mentioned, which again I see as a very much in line with what we do here, not to the same scale, but in terms of principles, very much the same. Removing latencies. We have a methodology we use around here called Project DNA, which is basically around that. It's lean project development. Talk to me about what things you guys have done internally in terms of your manufacturing capabilities in order to enable that.
Yeah, well, really investing in the right tools and equipment it's an undeniable reality that that a company like ours needs to do. So vertical integration at every scale, micro and macro, is really, really important. Understandably, we found that to be sort of a unusual concept, especially here in Canada, where startups very rarely form in the hardware space, and when they do, they're oftentimes leaning heavily on small amounts of government funding to get off the ground in their initial years, or not really making CapEx style investments that help them scale, iterate. And these are high risk investments because these pieces of machines for a young small company, they are not cheap, and they take a lot of effort to set up and master and all of that. I mean, we're not hiring people necessarily who are deeply they're deep experts with any of these machines. We teach ourselves how to use them, and that's what's allowed us to move that quickly, really, is because we take on sort of the initial risk, technical risk, financial risk, bring in these capabilities, bring in the right team members and into the team, and we work through problems, not just technical design problems, but manufacturing problems. Our core philosophy around even our rocket program is really to minimize the rocket science as much as possible and just build something that works. Getting to orbit is more important than exactly how we get there. So we're, physics and materials and all of that, we're relying on things that have been proven for decades. And we're really focusing on manufacturing, operational excellence, logistics, scaling, in every other way, so that so we maximize our chances of success. And in-house manufacturing plays the biggest role in that. So I would credit that among the amazing team we have to how we've been able to move that quickly.
Yeah, it's that combination of tenacity and flexibility to understand that really oftentimes the simplest solution is probably the best one, and you don't have to create this very elaborate thing that nobody can understand because it just becomes more difficult to manage. It's right. Very, very, again, similar to what we do here. I know one of my coworkers, Kyle McDonald, did have the opportunity to visit your facility, I think in the fall maybe, or the summer, and he was telling me about how similar he thought you guys were to us in terms of principles of problem solving, but also more importantly, I guess, how amazing some of the solutions that you put into place are. I won't disclose any of those things that he told me because I don't know if you want me to, but it's very interesting to say the least. I did want to ask, so you talk about how the vision for Nordspace is to develop all of these things, from a launch vehicle to a rocket, to the launch site, et cetera, et cetera. I noticed that in order to implement a solution for your engines, you guys decided on metal 3D printing. Can you talk to me about some of the challenges that you may have faced with that, or has that been a good technology for you? What do you know about that? Because that's something that I'm really interested in, and I don't know too much. I'm a little bit ignorant on the subject.
Yeah, it's a breakthrough piece of technology for a lot of reasons. On its own merits, of course, the technology is incredible, but also in this day and age, the price of implementing that technology has come down so much that it really is. It's still a high barrier to entry, especially for startups, but it's very possible to use this technology in a startup setting, acquire it, and maintain it in-house. And leverage it. So, Metal additive manufacturing in our use case has a bunch of advantages. Of course, we can build very intricate designs, especially with detailed internal geometries. As an example, our engines, being liquid rocket engines, require cooling systems, and we have regenerative cooling, which manifests as cooling channels that run through the body of the engine. Now, if you were to traditionally manufacture something like this, if you wanted to have cooling channels within the rocket engine's body, very difficult. These are oftentimes extremely small cooling channels, and they can't have any imprecisions with them, or dust or particles in them or anything like that. Or you like braze on channels on the surface of the engines, and it's like, it's an imprecise and messy situation. Versus with additive manufacturing, we're able to manufacture these engines with the cooling channels embedded in them. That's just one example. Similarly, with other things like injectors and all of that, what we were able to ultimately do is take down the part count from what would traditionally be maybe 25 parts for a rocket engine down to one part. And that sounds great, and it is now, but it took a really significant amount of R&D and many mistakes to sort of get that right. One example that I can offer is we're fusing powders. Basically, that's what powder bed fusion ultimately is, layer by layer. And many of our parts, not just engines, but pressure vessels and things like that, have very shallow angles that need to be bridged, not unlike maybe plastic printers. But when you have powders that can literally fall through, that's very hard to do. We've developed techniques to bridge very shallow angles to produce really high quality prints at those shallow angles. And we're pushing ultimately these parts to extreme limits, extremely high temperatures and extremely high pressures, and testing overall the material science of fusing millions of little welds on these powders together to produce something that actually works. So it's not without its challenges, but this is absolutely a groundbreaking technology that we're privileged to be leveraging in this day and age.
Yeah, it sounds like it goes back to that same idea though about creating simplicity where there is some. So rather than dealing with all of the complex variables where the quality standards are so high, go around them with a new technology, and that makes things work. So going back to an earlier comment that you made about your farm team, I guess, and kind of cultivating culturally aligned individuals that then can perform in your business and in others around the country and around the globe. Why is that important to you?
It's so important. Well, it's so important for so many reasons. But first of all, I feel like everything I am today, professionally, personally, even, is because I'm a product of that whole student experience. It's hard being a student for a lot of reasons, certainly, but I feel those teams, those engineering experiences really saved my butt in a lot of places where, I was losing interest in school in certain places, or maybe going down not necessarily the best paths. But then you get to be a part of these teams that are building these rockets or robots or satellites or windmills or drones or whatever it may be. And you really get to put into practice these very technical skills at a very young age and gain practical skills. And I think that's one of the things that's often missing in a lot of engineering education, is just the practical skills. A lot of times we interview folks who haven't developed any practical skills, and they're excellent engineers on paper, but really we don't know what to do with them when they show up in the interview, or if they show up to work potentially. They're not ready. And it's extremely important, I think, for a well-rounded and balanced engineer to have both practical and strong theoretical skills. Also, I think it's really important to provide students, the way you all did at Protocase and Protospace, the support and the opportunity, and just the sheer notion that, hey, there are adults, or there these large companies, at least they seem really large when you're a student, you don't know better, that support you and that care about you and think that the work that you're doing is important. And just somebody telling you that the work that you're doing is important is oftentimes motivation enough for that person to stick to what they're doing, and then eventually go on and take leadership roles at large companies, or found their own companies, or whatever it may be. But supporting them in that way is really important. That's why at Nordspace, and many thanks to you and some of our other sponsors, We now sponsor and support about 15 student teams building rockets, robots, and satellites, and intend to increase that significantly over time because it's just so important, and it's so important to the future of Canada.
Well, that's really amazing. I'm sure that the impact will definitely be felt. So, what about Nordspace in 5, 10, 15 years? Where's the long-term goal for you of Nordspace and I guess more broadly, space exploration in Canada?
Yeah, I mean, we think about this a lot of the time. For me, we're really focused on delivering an essential capability. We think for a sovereign nation like Canada, having access to space, this is not some final frontier. This is no longer about space exploration just yet. It's really about delivering something that we as Canadians must have access to. Right now, we're completely dependent on other nations to get even our smallest literal shoebox sized payloads into low Earth orbit. And just delivering that basic capability is our focus right now for the next many years. That itself is a major challenge, but that would set the foundation for us to build larger vehicles and ultimately our own space program that can maybe one day support human exploration and deeper space exploration. But right now, really, we're focused on just building an essential piece of infrastructure and an essential capability for Canada, much like we have, ports for the sea, or airports for air, and roads and railways and all of that for land. We consider and should consider space as a critical domain. And really, it's about building kind of the road to space that's of greatest importance to us. Space exploration is something obviously I'm very excited about, but for the time being, it's about getting satellites into orbit that can help us monitor and prevent wildfires, that can help us understand our oceans, that can connect remote Canadians, that can secure our borders, that can create opportunity economy for other space companies to know that, okay, wow, we have a spaceport, we have a launch vehicle, we can build a satellite company that solves X problem because we don't have to ship our satellites and take on all the overhead or just move to the US. We can do this here in Canada and build our economy up that way. So I think it's really practical for the next few years for us. And I'm trying not to get too excited about the exploratory aspect of it, but we'll get there.
Absolutely. Yeah, it's, I see the vision now. It's really creating that infrastructure to stabilize thing and then kind of go from there. After chatting with you and learning about your company, I'm fairly confident. I'm very confident, I should say. You guys will get there and more. I think you're far too modest. It's really impressive what you've done so far, and I'm sure what you'll continue to do. So thank you so much, Rahul. Inaugural guest of the ProtoPod. Pretty special. I don't think we could have picked anybody better. So all the best to you and your team, and we look forward to maybe having a chat in the future.
That's so kind of you. Thank you again for the opportunity and for everything you all do at Protocase. You're amazing. Thank you.
Thank you, Rahul. Bye, everyone.
Bye.